2. And we can see that energy tends to come up on paper 1 and 2. So it's a good topic to spend some time learning. Describe with the help of a diagram an experiment to show the difference in emission. Now take care here, emission of heat from dull black and shiny white surfaces. The experiment that we would have done in class on this involved using what's called the Leslie's cube. And the cube has different surfaces on each side of it, and it's filled with hot water. And this is the experiment that I would recommend you describe. For the diagram, if you draw your cube, I'm sure your diagram will be much better than mine, and identify the opening at the top, and we're going to pour in hot water. Then we must identify 2 of the surfaces and describe them. So for example, this one could be the dull black surface, and this one could be the shiny white surface. That's how we're going to produce the radiated heat, but how are we going to measure it? Well, what we need to do is draw in and label an Edspot galvanometer. This detects radiated heat, and then you can read it on a galvanometer. So that's the diagram for the experiment, but we must still then describe the experiment. First of all, the first point is we pour hot water into the cube and put the lid back on to ensure that you don't lose a lot of heat by convection. Then we measure the radiated heat given off by each surface using the Edspot galvanometer. When we're measuring that radiated heat, one of the things we need to be careful of is that the Edspot galvanometer is at the exact same distance from each surface. So hold the Edspot at the same distance from each surface. And then the final thing to ensure that you're explaining how the results make sense, or the results tell you about the difference in emission, you must say that the greater reading on the galvanometer identifies the better emitter. So the diagram will get you a mark. The second mark would be about measuring the radiated heat given off. There should be heat in there. By each surface using the Edspot galvanometer. The third mark would then be for explaining how you must have the same distance from each surface to ensure a fair test. And then the final mark is for identifying the greater reading tells you which surface has a better emission. B part 1. Name the particle mainly responsible for the transfer of heat through a good conductor of heat, such as copper. Whenever you see conductor of heat, we are always thinking about electrons, as it's the electrons carry the heat through the material. Part 2 follows on from the part 1 where you identify the electrons. Describe in terms of this particle, so we must refer to the electrons, how heat applied at one end of a good conductor passes through to the other end. Right, So we're talking about the electrons. The heat increases the kinetic energy of the electrons. At the end at which it's applied. The electrons move and transfer or pass on the energy by colliding with other particles. So these collisions pass on the energy. So 3 marks. First mark is heat increases the kinetic energy of the electrons. The second mark is for the electrons move and pass on the energy. And the third mark is for the collisions. You must emphasise the collisions here along with the electrons moving as how the energy is transferred. The next part of that question follows along the same idea, but instead of talking about conductors this time, we're talking about an insulator. So, name the particle mainly responsible for the transfer of heat through a thermal insulator such as glass. Well, the conductor was about electrons. The insulator is about atoms or molecules. Either term is acceptable. Whenever we're talking about glass specifically, your better term is molecules, as glass is made up of molecules. Part 4. Describe in terms of this particle how heat applied at one end of the thermal insulator passes through to the other end. So it's essentially the same question as for part 2, but we're applying it to the insulator this time. There's a fundamental difference. The heat makes the molecules, and remember you must refer to the molecules because it's in terms of this particle. So you must refer to the molecules. So heat makes the molecules at one end vibrate more. And that's where your essential difference comes in. It's the molecules and vibration is different to the conductor, which is electrons and movement. So heat makes the molecules at one end vibrate more. They pass on the vibration or heat energy to neighbouring molecules. So in this case, again, 3 marks. So we're talking about heat makes the molecules at one end vibrate more, and they pass on the vibration or heat energy to neighbouring molecules. In this case, you must refer to molecules and vibration, not, absolutely not, collisions or movement. The terms collision and movement belong with the conductors. When we're talking about insulators, we're referring to molecules and vibrations. Those are the key terms that you must identify.